Hello everyone, my name is Alison Robertson and I'm an Extension Field Crops Pathologist here at Iowa State University. And in this episode of Crops TV, we're going to be talking about tar spot. Tar spot has been reported in every county in Iowa, and so we know that it's present here. However, the disease tends to develop late in the season, and so a lot of my trials that I've put out in collaboration with other colleagues out east, we haven't got tar spot developing in those trials soon enough for me to be able to collect data. And so therefore, I'd like to say a big thank you to Darcy Telenko at Purdue University, Damon Smith at the University of Wisconsin-Madison, and Marty Chilvers at the University of Michigan, because a lot of the slides that I'll be sharing with you today are from trials that they have done. So first of all, let's go over tar spot symptoms. I suspect that most of you have seen tar spot because it was present in most fields in Iowa in 2021. But tar spot are these little black spots that you find scattered on the leaves of corn plants. They have the appearance of splattered tar. And that's why it's called tar spot. You may also see these tar spot spots, or stroma as they're called, on the husks of corn ears as well. Sometimes with the tar spots may be surrounded by a halo of dead tissue, and we call this type of symptom fisheye. This symptom is not that common. You will see it occasionally, and we don't really understand why this symptom is occurring. In the older literature, this symptom was associated with another fungus that was co-colonizing that tar spot symptoms, but we have not found that fungus here in the United States, and so we're still trying to work out why some of these tar spot stroma get this fisheye symptom around them. Tar spot will also cause premature senescence of corn plants. And as with any foliar disease, because tar spot impacts photosynthesis and then leads to cannibalization of the stalk, a secondary symptom associated with tar spot is stalk rot. So as you can imagine, there are lots of lookalikes that you can confuse tar spot with. And this is a couple. So early on in the season, you may see black spots on the leaves that are very circular. If you can wipe them off or scratch them off with your fingernail, this is not tar spot. So this would be something like bug poop, or also dirt, moldy pollen can look a little bit like tar spot. So what you want to be looking for is you want to be looking for irregular shaped spots. And I know that I have a cluster of spots here, but oftentimes the first time you see tar spot on a plant in the field, there will only be one of these spots, okay? For the most part, these spots are kind of irregular in shape. They also bleed down the vein, so I've used those arrowheads there just to point out how these spots have tails or bleed, as I like to say, down the veins. The other thing about these spots is they will be slightly raised, and you can see the spot on the top of on the upper leaf surface, but if you turn the leaf over and look at the underside of the leaf, you will see the same spots there. And basically, this is because these spots are just a mass of fungal mycelium that has grown together. And so it's almost like tiny little sclerotia embedded into the leaf of the corn leaf. And within these little stroma, or within these fruiting structures, that's where the spores are produced inside of them. Another thing that you can get, that it's quite easy to get tar spot muddled up with, is rust, common rust and southern rust. So remember that even though these rusts produce those orange spores earlier on in the season, once we get into September, those pathogens change over and start producing these black teleospores instead of orange iridospores. And so sometimes it's easy to get these muddled up. And so this slide here on slide A will show you tar spot symptoms, but that yellow arrow is pointing to a southern rust pustule with the teleospores. And then on slide B, that white arrow is pointing to a tar spot lesion. You can see how it's kind of elongated along the veins, but you can see the rust pustules there. And so one of the things you'll notice about the rust pustules, if you can get a hand lens or if you've got good eyesight, you'll see those pustules bursting through the epidermis of the leaf tissue, whereas with tar spot, it's kind of this black fungal mass embedded in the leaf tissue. So this shows you a map of the distribution of tar spot, and what you'll see is those darker colors are where tar spot was first reported in 2015, and then you can see how the disease has spread since 2015. And so in 2021, you can see the disease continued to spread. It was reported in 4 new states. This map just shows the Corn Belt, but the tar spot has also been reported in Florida and Georgia. And there you can see there in Iowa that every single county has now had tar spot reported from it. So the fungus that causes tar spot is called maydis, and this is the possible life cycle of this disease. We're still learning a lot about the pathogen and about disease development, but we know that the pathogen is able to survive in infested residue in those thick black stroma that are embedded in the leaf tissue. The fungus will survive, and there's a couple of publications that have come out recently to show that that fungus will survive a Midwest winter. And then what will happen is under moist conditions in the spring, that fungus will start to ooze out spores from that stromata. And so you can see that picture there showing the black stromata with kind of salmon pink, orangey ooze kind of emerging from it. Those contain the spores, and then those spores obviously get splashed onto the leaves or get wind dispersed onto those leaves. And when we originally thought that it was pretty cool conditions that we needed for disease development, but in 2021 we had a pretty warm growing season. Very wet, as I'll show you just now. But so we're not entirely sure what the best temperature is for disease development, but those spores will land on those leaves and then infect those leaves, and approximately 14 days later we'll start to see those symptoms or the signs, the stromata. And then obviously, with moisture, those stromata in that leaf tissue will ooze more spores. They will then get distributed across that leaf to new leaves, and therefore we get this multiple cycles of this disease, and that means that we get more and more and more stromata developing on those plants in that field, more severe disease, and therefore affecting production. So one of the things that we know is that environment drives tar spot, as it does with any disease, right? And one of the things we know is that moisture is incredibly important. And this is a slide from Marty Chilvers, from someone in Michigan, showing a field with center pivot irrigation. And you can see that even though this field had a fungicide application at R1, you can see that where the irrigation was, where the pivot was, that there's much more severe tar spot than on that corner of the field which didn't receive as much moisture. So we know that leaf wetness is a driving factor, and if we look at this map from NOAA, which shows the precipitation departures from average, what you'll see there is that Wisconsin, Illinois, Indiana, Michigan, where they had very severe tar spot in 2021. They were very, very wet, whereas here in Iowa, we were exceedingly dry. And so it wasn't until the end of August when we started to get those late growing season rains that we started to see tar spots show up more and more and across the whole state. So leaf wetness is very, very important for this disease. This disease can develop very rapidly. So once again, some slides from Marty in Michigan, but this is in this field. Tar spot was observed on July the 8th. And then on August the 24th, this is an aerial photo of the field, and you can see a patch of corn that's starting to die prematurely from that tar spot. And within 2 weeks, that whole field was had completely matured, but just died from that tar spot. These are some similar slides from Darcy, from a publication that she has in Plant Health Progress that will be in press. But once again, here you see September the 21st, 2019, and you see the corn, it's looking pretty good. And a couple of weeks later, you can see how that tar spot has just completely ravaged that crop. So the thing about tar spot is it can develop very rapidly, as I'm sure most of you are hearing out there. And so that's what's scary about it, and that's why we have to think about how to manage this disease. So we are doing, there's a lot of research going on to answer the questions about tar spot and how do we manage it. And so we have coordinated research trials across the Corn Belt. Iowa takes part in those trials. And then we have disease tracking, where we're tracking where the tar spot is through our diagnostic clinics, through our extension specialists, through industry, and then those reports of the disease are uploaded onto ED Maps or the Corn IPM Pipe website. Then we have trials looking at fungicide efficacy. We have trials looking at fungicide timing. We have trials that are looking at model development, and then we're also looking at integrated disease management. For example, resistant hybrids with or without a fungicide. How does that help manage the disease? And Iowa State takes part in most of these trials, all of these trials, and unfortunately, we just haven't had enough disease in those trials yet to be able to contribute data. So remember, when we're thinking about managing tar spot, this takes us back to the disease triangle. So we have this virulent pathogen. We know that it can survive the winter in Iowa. We know that it's present in every state in Iowa. And we know that it can move. We also have corn planted across the state, and corn is susceptible to this pathogen. I'll talk a little bit about hybrid susceptibility. And we also know that corn is susceptible to infection by this pathogen at all growth stages. So Damon has some reports where he has seen volunteer corn in a wheat field at growth stage V4, V5, V6, and it has tar spot on it. So we know that at all growth stages, corn is susceptible. And then the environment, we're learning about the environment. What is the favorable environment? And so what temperatures favor it? We know moisture is very important, as with any fungal disease, and leaf wetness plays a big role in infection and disease development. Okay, so let's have a look at hybrid resistance and susceptibility, and this was some work that was done a couple of years ago, and this publication is available on the Crop Protection Network. But this is data from Wisconsin, Michigan, Illinois, and Indiana with a number of hybrids and the amount of disease on the x-axis, so what the severity was. When we say severity, we mean the percent of leaf tissue that had the disease on it, and then we have yield on the x-axis. And so we then what Darcy and her colleagues then did was split the hybrids into early maturing hybrids and later maturing hybrids. And what you can see is on those later maturing or longer season hybrids, the slope of the graph is a little more steeper, and so suggesting that we get greater yield loss on longer season hybrids, which kind of makes sense. You know, the disease has more time to impact the corn. So another thing that we learned from these studies, or that we're learning, is that there's no commercial hybrid available that is completely resistant to tar spot. So everything that we grow will get tar spot, but the susceptibility will vary across the hybrids. And so I know that seed companies have been doing a lot of work collecting data, and they're getting a much better idea of what hybrids are less susceptible to tar spot than others. And so if tar spot has been a problem on your farm, or if you're very concerned about it, one of the best things you can do is plant a hybrid that's less susceptible to tar spot. And so I would encourage you to talk with your seed dealer. Okay, fungicide field trial. So this is a fungal disease, so we know that fungicides are going to be able to control the disease, and there's a couple of questions out there, right? Are some products better than others? And then what growth stage is best to control this disease? And so we've been doing fungicide trials across these states to try and answer these questions. So the first question, are some fungicides better than others at reducing disease severity? So these are fungicide products that have been evaluated for efficacy, and we have some older products in there, for example, Headline, which is just a single active ingredient. The strobilurin, we have the Tilt in there, which is just that single DMI. And then we have our mixture, fungicide mixtures, all the way up to the newer products. And so these have been tested, and this publication is in press, so I have it down there at the bottom, and you can see that data. But I'm going to show you some of the data from Darcy. So this is Darcy's fungicide trial in 2019, and what you can see on the left, the vertical axis, is the AUDPC, which is the area under disease progress curve, which is basically similar to cumulative aphid days. It's worked out exactly the same. So in 2019, at this trial, tar spot was first detected on the 13th of July. And then Darcy measured the amount of disease on the ear leaf, 2 leaves below the ear leaf, which would be ear leaf -2, and then 2 leaves above the ear leaf. So that would be ear leaf +2. And you can see that first bar on the left is the untreated control. And then we have the list of treatments that were in this trial. And you'll see those letters there, A's and B's. And so basically, if a bar has the same letter as another bar, that means that they were not significantly different. And so what this trial showed in 2019 was that a fungicide reduced disease, and there were really no differences between the fungicide products. So this trial was repeated in 2020, and here is the data for that trial in 2020, laid out exactly the same as for 2019. Tar spot was detected 2 weeks later in this trial on the 28th of July. And in 2020, it was kind of interesting because we started, or at least Darcy started to see that some of the fungicides were starting to separate out from others. And so you can see that some of the newer products, the Revitake, the Valtima, and the Delaro there have different letters compared to the other bars, and so significantly reduced diseases more than others. So we know that all fungicide products will reduce tar spot severity, and the 2020 data suggested that the newer products that are available on the market may be more effective, particularly when disease pressure is high. And so I know that from the 2021 data that Darcy shared at the Corn Disease Working Group meeting last week, which would have been the second week of December, that once again, it is looking like those newer products are more effective at controlling disease under high tar spot severity. So when disease severity is a little lower, we can probably get away with one of those older, more cheaper products. Okay, so another question that I've heard a lot of is when during the growing season should I be applying my fungicide to protect my crop against tar spot? And I know there's been a lot of talk out there that maybe we need to go in with 2 fungicide applications, especially considering what 2021 was like out east, where tar spot was very, very severe. I want to remind you that 2021 was also much wetter. Remember the map that I showed you? So much wetter out east, and more than likely contributed to more severe disease out there. So once again, some data from Darcy, showing you the same way. So we have the AUDPC, the area under disease progress curve on the vertical axis. On the horizontal axis now, we have the growth stages at which the fungicide was applied and the dates, okay? You'll see that this is the 2019 trial, and so the disease was detected on the 13th of July in this trial. The model that you see on the far right refers to the tar spotter model, and that was never activated in 2019. So we never got the right conditions for that tar spotter model to be able to tell Darcy to go ahead and spray. Excuse me. So if we look at the data, we have all the way from V7, V9, V10, then that tasseling application R2, we have a double application of V7 plus VT, and then the model. And what you can see is that in 2019, the best time to apply that fungicide was between VT and R2, and that's where we got a significant reduction in the amount of disease. Yes, that double application was not significantly different from the VT R2, but it wasn't better. Okay, if we move on to 2020 now, so once again, so remember the disease came in 2 weeks later here. Darcy has basically the same timing, V8, V10, VT, R2, R3 up to R5, and the model and that double application. And so what you can see here is that R2 application was the best timing to reduce disease, and it was similar to that double application timing of V8 and VT, but the double application was not necessarily better. If we move on to look at the yields now for each of those application timings, so this is 2019 on the top yellow bars, and then 2020, the bottom yellow bars with the same treatments down there, and I've just tried to line them up by when the fungicide was sprayed. And so what we see here is that the greatest yields occurred with that VT or that R2 application, which you will remember reduced the disease the best in both years. And sure, that double application, we're also getting greater yields, but those yields are not better than that tasseling application or that R2 application. And so you wouldn't necessarily get greater yields to be able to pay for that double application. So that's Darcy's data from Illinois, but I wanted to show you some other data from across the Corn Belt. And so this is 6 locations with tar spot data. So 2 locations in Wisconsin, 1 in Michigan, 1 in Indiana, and then 2 in Illinois. And so once again, we have that area under disease progress curve kind of score on that vertical axis. And in this experiment that was done, only Trivapro was sprayed. And the Trivapro was sprayed at V6. There was a model application. And then we have an application at V8, V10, VT, a double application, and an application at R2. And from across these trials, the best timing in 2019 for that application of fungicide to reduce disease was VT and R2, and that double application was not different. So spraying a fungicide twice did not control disease any better. If we look now to 2020, this is in low disease environments. So those are at Wisconsin and then at Indiana. And if you look at the timings along the bottom, they are not in order of growth stage. They are in order of disease control. And so, but what you can see once again is it's those applications that were R2 gave us the best disease control, but that R3, R4 application were also giving some control. We have the tar spotter in there, so that helped reduce disease, and we have that double application. But once again, that double application is no better than a single application later on during the growing season. If we look at high disease environments, we can see that the double application and that R2 application gave very, very similar disease control, but and then that the VT and the R3 application were not different from that R2 and double application. So both reducing disease. And remember, this was with Trivapro or Trivapro. Okay, so if we think about timing of application is going to depend on when tar spot starts to develop. So if it develops early on in the growing season, it's possible that we might need to come in early and apply a fungicide. But if it develops later, it's, applying that application at V2 to R2 should be able to help reduce tar spot severity. And I think, for Crops TV, most of you are going to be in Iowa. And so this is the way that I would go here in Iowa. Out east, where they have irrigation, that's going to contribute to leaf wetness and is going to help with the development of the disease. But here in Iowa, where there's not a lot of irrigation, we're just relying on that precipitation in a normal growing season, whatever that is, or a growing season where we don't have a lot of regular precipitation events. We're not going to see this disease. I don't think we're going to see this disease just develop as quickly as it does out east where they have that irrigation. So in some years, 2 applications may be necessary, but I think that's going to be very rare here in Iowa. For the most part, I think that an application at VT to R2 is going to be sufficient to control the disease. Okay, so if timing of a fungicide application is important, how are you going to know when to spray? So there is this app that I've talked about. So this was developed by Damon Smith at University of Wisconsin. And this app is available on both Apple and Android phones. What the app does is it predicts tar spot. So you can enter in your fields that you're keeping an eye on, and then you get to answer some questions. So whether a fungicide was applied or not, and what the growth stage of the crop is. And then the model works on a 30-day moving average of mean temperature, mean dew point, and total rainfall. And from that data, it predicts tar spot. And this app has been running now for 2 or 3 years. It's an app that is continually updated. So the more data Damon receives about it, the better the app is going to get. But last year, I believe that it worked very well for, especially out east, for predicting disease. So that's one way you can see whether your fields are at risk for tar spot and when that tar spot should become an issue, and then whether you need to apply a fungicide or not. The other thing that you can do is you can go to the Corn IPM Pipe website, and this is a website that is in real time. So as soon as I get reports of tar spot from any county, it could be from one of the ISU extension agronomists, it could be from agronomists out there in the field who are contacting me via Twitter or via email. As soon as I hear a report of tar spot that comes along with a photo so that I can verify it, that county gets turned orange on the map, and then you know that tar spot is present in the county, which kind of gives you an idea that you've had conditions that you've probably had conditions in your area that are good for tar spot to develop. And so it might be an idea to get out in your fields and to scout and to see if you can see any disease. So as we look forward to 2022, what can you do to manage tar spot? So the first thing to do is to assess the risk. Okay, so has it been reported in your county? Look at that Corn IPM Pipe website and see if it's been reported in your county. If it has, get out into the field and scout. Another thing you can do is talk to your seed salesperson about hybrid resistance. Even though no hybrids are resistant, some hybrids are less susceptible than others. If you're applying fungicides, one of the best things you can do is leave a check strip or multiple check strips. Only by leaving check strips are you going to know whether that application was successful or not. Did it reduce disease? Did you apply that fungicide at the right time to reduce that amount of disease? You can help monitor disease occurrence either by sending samples to the diagnostic clinic or to me or Darren. You can send us photos via email or via Twitter, and we can help verify whether that's tar spot or not. The other thing to remember, especially here in Iowa, is that we have other diseases, right? And so gray leaf spot, northern corn leaf blight, those diseases are still important. Don't forget about them. So remember to manage for those diseases as well. And the bottom there, I have a link to the cropprotectionnetwork.org, and the picture that I'm showing there, Fungicide Efficacy for Control of Corn Diseases. This is a publication that is updated every year using data from our fungicide trials. So all of the corn pathologists in the US contribute to this publication. We update, and this is a great publication for if you have tar spot or gray leaf spot or northern corn leaf blight in your field. What is the most effective fungicide that you can apply to manage that disease? So for more information on tar spot and other field crop diseases, you can go to the Crop Protection Network. So that's where you can find that fungicide efficacy publication. There was also there's a couple of publications there on tar spot as well as other diseases. There's some really neat tools there. There's a tool that can help you learn how to assess disease severity on a corn leaf. So there's that kind of tool. And then there's also webinars and other resources posted there. So I encourage you to visit the Crop Protection Network. So I'd like to thank you very much for watching this episode of Crops TV. If you have any questions, please feel free to email me. My email address is there, alisonr@iastate.edu. You can also follow me or ask me questions on Twitter. Thanks.